All right, so we're going to start with 9-1, quadratic graphs and their properties, okay? So first and foremost, I copied this part for you. A quadratic function is a nonlinear function, and the rate of change is not constant. So it's not a linear situation where it's going up and up and up by the same amount each time, right? It's either rising at a rate and then it's slowing down. Like if you think of a rocket, right? It starts off going really fast. What happens as it goes up? It slows down, doesn't it? Until it gets to a point where it then reaches its maximum spot, right? And then what happens? It starts going down again, and the rate is now negative. It's going down, okay? And so it's the thing is that a graph of a quadratic function is a symmetric curve, meaning it's the same on both sides, and it's got a highest or lowest point corresponding to the maximum or minimum value, okay? All right. Quadratic functions have this format right here. Y equals, this is the basic format. Y equals ax squared plus bx plus c. That should look familiar to you because in chapter 8, we factored those where we had ax squared plus bx plus c, right? Now it's y equals that. We're going to figure those out. Now, there's all kinds of formats, okay? The key is that the degree is 2, okay? The highest degree is 2. So the simplest quadratic function is this one, f of x equals x squared or y equals x squared. This is called the parent function, okay? And we will, in this chapter, be comparing everything to the parent function of y equals x squared. All right, the graph of the quadratic function is a U-shaped curve called a, oops, and I didn't leave enough space here, parabola. Okay, the U-shaped function is a parabola. The parabola with the equation y equals x squared is shown at the right. Here is the parent function, y equal x squared. That is shown here. It opens up. You can fold a parabola so that the two sides match exactly. The property is called symmetry. The fold line, or the line that divides the parabola into two matching halves, is called the line of symmetry. All right. The highest or lowest point of the parabola is called the vertex. Okay, so the highest point or the lowest point is the vertex, which is on the axis of symmetry. The highest point of the parabola is the vertex. The parabola opens upward if the first coefficient, a, is greater than 0. It will open up like a U. If a is less than 0, it will open down and make like the more of like a rainbow shape, okay? If it opens upward, right, then it has a minimum point. But if it opens downward, it's going to have a maximum point. And it'll look like these two. Okay, so that's the opening. So this is how we start. So this is just the introduction. And so this copy is not super good, but it says, what are the coordinates of the vertex of each graph? What is its, is it a minimum or maximum point? So the vertex is the highest or lowest point. So at this, right, this is its highest point right here. That's its vertex. So what would be the ordered pair of that vertex? Go on. 0, 3. X is 0, y is 3, right? That's the coordinate. Is that a maximum or a minimum?
Maximum.
That's a maximum. Pretty easy to see, right? This one, this parabola is opening upwards, and so the vertex is now here, right? That's its lowest point, so clearly that's a maximum or a minimum. And give me the ordered pair for that one, David. Go ahead.
1, -1.
Correct. 1, -1. So that's the first introductory of that. Now, as we get going through, it's going to ask you, and that's going to correspond to a time, right? how many seconds it takes it to get to its maximum, and the actual distance in feet. Okay? All right, turn it over. This is where we're going to use our graphing calculators, and they're going to be important. So, and where if it needs you to be more specific, we'll use the table on the graphing calculator. So, you're both of them. Yep. So the first one says graph the function y equals 1/3 x squared. Make a table of values. What are the domain and range? Okay. So we're gonna start by let's clear out all our calculators just to make sure that we are all on the same page. So press second plus 7 to reset it, 1 for all RAM, and 2 to reset. And our RAM should be cleared. Let me zoom this out a little bit. Okay, so we're going to clear our RAM. And now we're going to go to y equals, and we're going to enter this function. So we're going to put in 1/3. So parenthesis 1 divided by 3 and parenthesis. And then x and then squared. And then we are going to, let's start by making the table, okay? So press second graph to get our table. Oop, my batteries are running low. All right. Oh, no, I'm going to have to replace my batteries or use someone else's calculator a second. I seal it. Let me seal Barwani's. Okay, thank you. All right, so here's our table. Let's start with that. So if we write the table down, right, we're going to write our x, y values here. So starting with x and y. Now, here's the thing. What I want you to do, though, when you do this is let's get some negative values as well, because if you scroll up, let's go -3 to 3, because this is going to be important. Look at -3. At that x value, the y value is +3. At -2, the y value is +1.3 repeating. That's 1 1/3. At 0, y is 0. And now what happens here? At 1, oh, I missed one, didn't I? Sorry, -1 was negative or +0.3 repeating, which is 1/3. Sorry, I missed that one. And then now +1, we're back at 1/3 again. And +2, we're at 1.3 repeating. And +3, we're at 3. So there's going to be this mirror image, right? So on every parabola, we're going to get some repeats. What do you think 0, 0 is? The vertex. That's right. See how 0, 0, right? It's the same left and right, or above and below this. This is the vertex.
So is 3 and 3.
Okay, so this is the vertex, and then as it goes outward, we have 0.3 and 1.3 and 3 and 3. It should mirror, right? So this is the vertex at 0, 0. It's going up on both sides at the same spots. All right, so we can use our calculator to graph, but sometimes we have to be more specific, okay? So what we're going to do to graph this now is we're going to make our XY axis. All right. And our X values are going from -3 to 3, right? Like this. And our Y values our maximum here is 3. So I don't have to go much more than that, but I'm going to go a little bit more than that. All right. So this is 1, 2, 3, 4. I'm just going by ones here. And I'm just going to graph them individually. -3, 3 is left 3 and up 3. And then -2, 1.3 repeating. We have to estimate that one's going to be right here. -1.3. Here's our vertex at 0, 0. And then it's going back up in the same fashion on this side. And is this a V shape or a U shape? It's a U, okay? Parabola, the quadratics should be a curve. It is not a V. A V shape, and they're going to keep on going. A V shape is going to be only when we have absolute value. The U shape, the parabola, is a U shape. So that's the graph. Now, you can see that on your calculator. Boop. So here it is on Barwani's calculator, right? But it doesn't look the exact same because this window is negative 10 to 10, right? And so
So can't we just zoom in?
you could zoom it in. Yep, you could do that. But this is the most exact graph. Now, it's asking us for something we haven't talked about in a while, and that is the domain and range. Domain. Is that our x values or our y values? Go. X. Those are our x values, and our range is our y values. So if you look at this graph on the calculator or the one we've drawn, our x values, right, going left and right are our x values. If that graph keeps going and going and going, does it go out to every x value? Would it go to every negative x value and every positive x value? Yes. So our domain is all real numbers, is what they would say. Okay, so it's every x value and every on the left and every x value on the right. So it's all the negatives, all the positives. Our range though, right? Our y values, look at our y-axis. Is that all real numbers? No. What's the lowest y value?
0.
Okay, so you can either say all real numbers greater than or equal to 0 in words, or you can say y is greater than or equal to 0. We know it's equal to 0, right? Because that's our minimum. And then it's everything above that. Cool. All right, now that's the next one is just showing, right, our table, our graph, our domain and range. All right, next one then. And we're going to use the calculator a lot. So in this one, use the graph below. What is the order from widest to narrowest of the graphs of the quadratic function? So what do you think we're going to do here? Put them all in. So let's go. Y equals. Now, the first one I want to put in, it says negative 4x squared. And I'm using Barwani's calculator. So sorry, Barwani, but thank you for letting me use it. And I'm going to put them all in at once. I'm going to put the second one in. Y equals parentheses 1 divided by 4x squared.
Where's the square button?
The squared button is all the way to the left above the logarithm button. See it? Everyone see that? Or you can use the caret key. It works the same. All right, the last one is y equals x squared, just plain. That's the parent function, we call it. And then remembering our order, it's already in there. Let's look, press graph. Here's our first one, y equal negative 4x squared. Y equal, 1/4 x squared. And then y equal x squared. Which one is the widest?
The one that's x squared.
Which one was that wide one?
The first.
No, the second.
The one with the fraction is the widest.
Why?
Why? Because you're multiplying by 1/4. So like your x squared, right? So it is going out at a slower rate than the other ones. Okay. So now the next widest is the negative 4 one or the parent function, the x squared. Yeah, this is the middle, right? We'll call that the middle because really the coefficient on that is +1. And this one is actually the thinnest or narrowest, right? So the rule is this. The closer you get to 0, the wider your graph will be for the coefficient. Okay? So that works for positive and negative. So we're going to write that down. Coefficients closer to 0 of A, right? Of X. So this is only our A value, not our B or our C. Closer to 0 are wider. All right, so if you get a fraction in there, it's going to be a wider graph than a non-fraction. So like if our coefficient on x squared was like 100, it's going to be a super narrow graph. Okay, it does look like a flower. All right, and so that's the next thing. All right, keep going. This is multiple choice, but it says, how is the graph of y equals 2x squared plus 3 different from the graph of y equals just plain 2x squared? So what do you think we're going to do this time? Put them both in and compare them, all right? So now let's go back to y equals. Let's clear out what we've got. Clear. So I'm going to put them in order, right? It says my first one is y equals 2x squared plus 3. 2x squared plus 3. And my second one says put in y equal 2x squared. Oops. Hold on. I pressed the wrong button there. Let's clear that out. 2x squared. Okay, let's graph that one. So here's 2x squared plus 3. Oh. And here's regular 2x squared. What's the difference? It moved it 3 units up, didn't it? So let's look. It shifted 3 units up, it shifted 3 units down, it shifted 3 units to the right, or it shifted 3 units to the left. Hey, if you did not get this, you type something in wrong. I'll get it after the video to help you. Okay? All right. Last but not least, our favorite story problems. Woohoo! These story problems are actually kind of cool, though. All right. An acorn, and this is true. You can predict a lot of stuff. An acorn drops from a tree branch at 20 feet above the ground. So 20 feet up, acorn drops. The function h equal negative 16t squared plus 20 gives the height h. So h is the height of the acorn in feet after t seconds. What is the graph of the quadratic function? At about what time does the acorn hit the ground? Okay, so we're going to put this in our y equals, instead of using h and t, right, we can only use x and y here. So we're actually putting it in as y equals negative 16x squared plus 20, like that. All right, here we go. Negative 16x squared plus 20. And then it wants us to graph this function. So I'm going to press graph. And this is what it looks like. Uh-oh. Can we see the top? No. So what should I do to my window? Increase the Y maximum, right? So I'm going to make the Y maximum 25. And I want to zoom this in a little bit. So I'm actually going to make my Y minimum only -5, and I'm going to make my X minimum only -5 also. All right. And I'm even going to make my X maximum +5. I want to zoom it in. Now let's press graph. Okay, where's the tree branch in this graph? How tall is it? This is my tree, my axis, right? Here's the branch right here where the acorn falls at the top. That's where it starts. Where's the ground? The x-axis. So that's what you're really looking at here. So let's draw a little picture of what we see here. So if I draw a little picture, okay, where is the tree branch up here? What height is that? That's 20. It gives us that this is 20 feet. All right, and then I'm going to draw my parabola in. Okay. Here is about 1, and here is 2, and -2, right? So this is the graph. All right. At about what time does that hit the ground? About I'm going to tell you 1.1 seconds. How'd I get that? The X value. Look is it right on the 1? No, it's not. It's just past it, isn't it? So we're estimating that using our graph. So that acorn drops. It takes just a little tiny bit over 1 second for it to hit the ground. Boop. And there you go. Now, we're going to get way more accurate with that. It's going to be great. Why is it not negative 1.1?
Because it's not.
It's time.
Can you go back in time?
No.
So this side, is this side really apply to this situation?
No.
It does not, okay? So math works, right? And sometimes in the real world, you only use part of that, right? We're not going back in time. Sometimes we wish we could go back in time and change stuff. But unfortunately, that's not how it works. Okay, there is the lesson. Today we're going to do the even numbers only on 9-1 practice, okay? Evens.